Now in the question 18, a box contains a marble. Eight of the marbles are blue and the red rest are red. Ken takes two marbles from the box at random without replacement. So, the part 1 complete the tree diagram. So, the total number of marbles is n, and the 8 marbles are blue. So, the rest are red. So, how we will write red marbles like? So, the red marbles will be n minus 8. Since if we take away 8 blue marbles from the total number of marbles, so we get red marbles. So now here we have the probability for the red marble in the first row will be n minus 8 over n, since the total number of marbles is n. Now for the second row, since the numerator remains n minus 1, since we have already drawn the one marble in the first row, so the probability, so there is already one marble is decreased due to taking or drawing one marble in the first row. Now if we have a probability for the blue ball in the first row 8 over 9, 8 over n, then for the red ball in the second row we have the probability n minus 8 over n minus 1, since the number of red balls is n minus 8. Now for the blue ball, we have the probability in the second row 8 over n minus 1, and for the red ball we have the probability n minus 9 over n minus 1. So now we have complete the tree diagram. Now on the part 2, the probability that Ken takes two blue marbles is 4 over 13. So the probability of two blue marbles is 4 over 13. So for the first marble to be blue is having the probability 8 over n, and for the second marble to be blue we have the probability 7 over n minus 1. Now we have 4 over 13, 8 sevens are 56, multiplied by 13 is equals to 4 into n minus 1. Now we have 4 into n square minus n, and after multiplying 56 and 13 we will get 728. So now since this 4 is multiplying here, so it will divide on the other side 728. So you know here n minus n square minus n. Now 728, 4 ones are 4, so here we have 32. 4 8s are 32, and 4 2s are 8. So here we have 182 n square minus n. Further we have n square minus n. This 180 on the other side will becomes minus 182, so is equals to 0. With the equation we have n square minus n minus 182 is equals to 0, so hence we have shown.
The question 18, part 3, we have to solve the equation n square minus n minus 182 is equals to 0. Now we will factorize 82. So here we have 2 9s are 18 and 2 1s are 2. Now we have 7 1s is 7 and 7 3s are 21, and here we have 13. So here we have 7 2s are 14 and 13, two factors of 182. So here we have n square minus 14n plus 13n minus 182 is equals to 0. Now we have common n from n square minus 14n. Now we have plus 13 common, and here we have n minus 14 is equals to 0. Now we have n plus 13 and n minus 14 is equals to 0. So here we have two equations, two factors. N plus 13 is equals to 0 and n minus 14 is equals to 0. So the first equation gives us the value of n is equals to minus 13, and the other one gives us n is equals to 14. So here we have two values of for n is equals to minus 13 and n is equals to plus 14. Now in the part 4 we have to explain why one of the solutions in the part 3 must be rejected. So the solution n is equals to minus 13 must be rejected because n represents the number of marbles which cannot be negative. In the part 5, find as a fraction in its simplest form the probability that Ken takes one blue marble and one red marble. So here we have two possibilities. The first possibility is the probability of blue then red plus probability of red then blue. Now from the tree diagram, the probability for the blue, and here we will apply the multiplication law of probabilities. So the probability for the blue ball in the first draw is 8 over, since the value of n is 14, so here we have 8 over 14 multiplied by, now the in the second row we have red ball, so here we have 14 minus 8 over 13 plus, now red in the first row we have 14 minus 8 over 14 multiplied by, now for blue ball in the second row we have 8 over 13 . Since we have 8 over 14 multiplied by 6 over 13 plus 6 over 14 multiplied by 8 over 13. Now we will make some simplifications where we have 2 4s are 8 and 2 7s are 14. Here we have 2 3s are 6 and 2 7s are 14. So here we have 6 4s are 24 over 13 multiplied by 7 is 91. So here we have over 91 plus, here we have 24 over 91 again. Now we have 91 in the denominator and 24 plus 24. So 24 at 24 is 48 over 91. The probability that the one blue and one red marble is equals to 48 over 91. And the question 19, bag A contains 20 potatoes, 4 of which are rotten. Bag B contains 12 potatoes and 3 of which are rotten. David selects one potato at random from each bag. So in the part 1, complete the tree diagram below to show the possible outcomes of David's selections. Since in the bag A, number of rotten potatoes is 4 and the total number of potatoes is 20 in the bag A, so the probability will be 1 over 5 for the bag A for the rotten egg. And since the probability for the rotten potato is given, so we can easily find out the probability for the good potato. So it will be 1 minus 1 over 5 and that will be equals to 4 over 5. So the probability for the good potato in the bag A will be 4 over 5. Now in the bag B, since we have 3 rotten potatoes and total number of potatoes is 12, so the probability will be 1 over 4 for the rotten potato in the bag B. Similarly for here, and for the good potato we will simply take away 1 over 4 from 1, so here we have 3 over 4. So the probability for the good potato in the bag B will be 3 over 4, and here again we have 3 over 4. Now in the part 2, David wants to find out the probability of selecting 2 rotten potatoes. He multiplies the probabilities along the RR branch highlighted in red, and he says that he using the multiplication law of probability. Do you agree with what David says? Explain your answer clearly. So the answer is yes. Both events of selecting a potato from each bag are independent of each other, because drawing a rotten potato from bag A does not affect the chance of drawing a rotten potato from bag B. Hence, when David finds the probability of combined events, he can multiply the respective probabilities of drawing a rotten potato from each bag. This is the multiplication law of probabilities. Now the question 20, a box contains 7 electrical components. The box was dropped in transit and one of the components became defective but not visibly. The components are taken out from the box at random and tested until the defective component is obtained. What is the probability that the defective component is the third component tested? So we have to find out the probability that the defective component is the third component tested. So the probability of first and second component are non-defective third is defective. So now we have to find out the probability for the first component, and that will be, since the total number of electrical components is 7 and we have to select one component, so here we have So here we have 6/7 probability for the first component to be non-defective. Multiply by using the multiplication law of probabilities. Since we have already taken one component, so the total number of components are left will be 6, and the probability for the second component to be non-defective will be 5/6. Multiply by. Since we have already taken two components, now for the third component, the total number of components are left will be 5, and the probability for the third component will be equals to 1/5. Now we will make further simplification, so 6 cancel with 6 and 5 cancel with 5. So now we have 1/7. So the probability that the defective component is the third component tested will be equals to 1/7. Now the question 21, a game is such that a fair die is rolled repeatedly until a 6 is obtained. Find the probability that in the part 1, A, the game ends on the third roll. So here we have the probability that first and second roll are non-6 and third roll is 6. So since a fair die has a total 6 faces, so the total number of outcomes will be 6, and now the favorable outcomes for the non-6 will be 5. And for the probability for the 6 appear on the die face will be 1/6, and so the probability for the non-6 will be 5/6. So now we have to use here the multiplication law of probability. So the probability for the first and the second roll are non-6 will be 5/6 multiplied by 5/6, and now for the third roll we have the probability 1/6. Now we have 25/216. So the probability that game ends on third roll will be equals to 25/216. In the part 1b, we have to find out the probability that the game ends on the fourth roll. So for this, we have the probability that first 3 are non-6 and fourth is a 6. So now here we'll use the multiplication law of probabilities. So for the first 3 rolls, we have 5/6 multiplied by 5/6 multiplied by 5/6, and for the fourth roll we have probability 1/6. Now we have 125 1296. So the probability that game ends on fourth roll will be equals to 125/100 1296. Now in the part C, we have to find out the probability that game ends by fourth roll. So for this, we have 4 possibilities. The first is game ends on first roll plus probability that it ends on second roll plus probability of it ends on third roll plus probability of it ends on fourth roll. So here we will write down all the probabilities. So the probability for the game ends on first roll will be 1/6, plus for the game ends on second roll we have 1/6 multiplied by 5/6, plus, since we have already find out in the part A the game ends on the third roll, and that was 25/216, and now for the fourth roll the probability was 125/1296. Now we have 1/6 plus 5/36 plus 25/216 plus 125/1296.
Now we are taking the LCM of these four numbers: 6, 36, 216 and 1296. So here we have 2 3s are 6, 2 1s are 2 and 2 8 is 16. Here we have 2 1s are 2 and 2 8 is 16, 2 6 are 12, 2 4s are 8 and 2 8s are 16. Now again we have 2 9s are 18, 2 5s are 10 and 2 4s are 8, 2 3s are 6, 2 2s are 4, 2 4s are 8. Now we have 3 1s are 3. Here we have 2 2s are 4 and 2 7s are 14, 2 1s are 2, 2 6 are 12 and 2 2s are 4. Now we have 2 3 9 27, 2 8 is 16 and 2 1s are 2. Now we have 3 1s are 3, 3 3s are 9, 3 9s are 27, 3 2s are 6 and 3 7s are 21. Here we have 3. We have 3 1s are 3, 3 3s are 9 and 3 9s are 27. Then we have 3 1s are 3, 3 3s are 9. Again we have 3. So here we have 3 1s are 3. So after multiplying all these factors, we will get LCM 1296. Now we will use the butterfly rule here. So 6 multiplied by 216, we get 1296. So here we have 216 plus 36 36. Now 36 multiplied by 36 gives us 1296. So here we have 36 multiplied by 5 plus 216 multiplied by 6 gives us 1296. So here we have 25 multiplied by 6 plus 1296 multiplied by 1 gives us 1296. So here we have 125. So now we have 216, 36 5s 180. Now 25 6s is 150 plus 125 divided by 1296. Now we will add up these four numbers: 216, 180, 150 and 125. So here we have 6 5 11 8 1 9 and 10 15 is 17, and here we have 2 1 3 4 5 6. So here we have 671 divided by 1296. So the probability that game ends by fourth roll is equals to 671 over 1296. Now in the question 21 part 2, suppose now that the game ends in such that the same die is rolled repeatedly until two sixes are obtained. So find the probability that in the part A the game ends on the third roll. So now we have the following two possibilities. The first possibility is 6, not 6, and the third one is 6. Plus, first is not 6, second is 6, and third is 6. So now by using the multiplication law of probabilities, for 6 we have the probability 1 over 6. For not 6 we have 5 over 6 multiplied by, for 6 we have 1 over 6. Plus, now again for not 6 we have 5 over 6. For 6 we have 1 over 6 multiplied by 1 over 6. Now we have 5 over 216 plus 5 over 216, and after adding up we will get 5 plus 5 over 216, and it will be equals to 10 over 216. Now after simplification with the help of table of 2, sorry, we have 2 5s are 10 and 2 1s are 2 and 2 8s are 16. So now the probability that the game ends on the third roll is equals to 5 over 108. Now in the part 2, we find the probability that the game ends on the third roll and the sum of the score is odd. So here we have the probability since there is a condition that rolled repeatedly rolled repeatedly until two sixes are obtained. So here we have two possibilities. The first possibility is odd number, then two sixes, and since we have condition that game ends on third roll plus probability of 6, then odd number, then 6. Now since on the face of a die three odd numbers appears 1 3 5, so the probability for the odd number to be appeared when the die is rolled, so it will be 3 over 6. So now we have to use here the multiplication law of probability. So the probability for the odd number will be 3 over 6 multiplied by, here we have 1 over 6 multiplied by 1 over 6. Now we have plus the probability for the 6 is 1 over 6. For the odd number it is 3 over 6, and for 6 it will be 1 over 6. Now here we have 1 over 2 and 1 over 2, and after making simplifications we will get 1 over 72 plus 1 over 72. Now after adding up we will get 2 over 72, and after making more simplifications we will get 2 1s are 2 and 2 3s are 6 and 2 6 are 12, so it will be equals to 1 over 36. So the probability that game ends on third roll and sum of the score is odd is equals to 1 over 30.